The reason you probably clicked on this video is because of the thumbnail and the title. Well, here it is. I finally finished the first iteration of my own homemade 3D printer. As I'm sure you're probably wondering, why is it that I made this printer? Well, ever since I heard of the idea of a rip-wrap printer, a 3D printer that prints parts for another 3D printer, I was very intrigued and had to try it for myself. Instead of trying to 3D print another 3D printer that had already been designed, such as the Prusa or one off of Thingiverse, I decided to go ahead and design my own. This choice made it quite a bit more challenging than it might otherwise have been. These challenges came in the forms of having to print the same part in various different configurations and iterations. I ended up using an entire kilo of filament just to prototype this one machine. Even now, with it all put together and assembled, I still have some tweaks I want to make. A quick overview of the printer itself. I have a clone E3D V6 hot end assembly, Bowden tube setup, and the extruder is 3D printed as well. My own design, though it also needs to be tweaked. It has a single Z-axis lead screw, and it is composed of a 5/16 inch threaded rod. I have 6mm
smooth rod
on all axes, and the bed is a glass plate. I'm using a GT2 belt for the X and Y axes, and NEMA 17 stepper motors for all axes, including the extruder. As you can see, it is true rip-wrap style, made out of threaded rod and 3D printed parts. Because I only CAD'd the printer itself and not the electronics, I forgot to include where they would go. I originally wanted to mount them on the back of the Z-axis right here, the board, and have the power supply mounted somewhere here under the Y carriage, but that was unable to happen as the parts were too big. I ended up having to build this box for the electronics to go in. These are the cords that go to the LCD, but currently not plugged in. I have the power going from the in to the board itself, and I have these USB cable stuck out for easy access. Inside it has a ramps 1.4 on top of a Arduino Mega 2560 and a 12 volt 10 amp power supply. One thing I forgot to mention is there is no heated bed on this printer, as that would require a stronger power supply, and I was on a budget for this. These are the first 5 prints. As you can see, they go from nasty to okay. This is the first print. It's supposed to be a 20mm cubed calibration cube, and as you can tell, it's pretty blobby due to the lack of a part cooling fan. I'll be adding one, hopefully. As I continued to print with this printer, I noticed that some of the prints were not coming out quite square. This is version 3 and 4 of the calibration cube that I printed. As you can see, they're not quite exactly square. That might not be obvious on camera, but when you compare them to a machinist square, I guess you would call this, you can quite obviously tell that the axes are not square, particularly in the Y and X axes. So, to improve this, I slightly modified the X and Y, and I ended up switching filament as well. So this is version number 5. So you can see it towards the top it gets under extrusion, and I have no idea what caused that. Well, actually I do. The extruder was not able to push down on the filament hard enough to get good enough grip on it, and that's what caused this under extrusion in version 5 and version 6 as well. Finally, moving on to version 7. So far, this is the best cube, and these blobs are just from it pausing. I was using Pronterface as a interface, and so the computer went to sleep and the print stopped. Now, after all those cubes, I was tired of printing more cubes, and so I attempted to print a vase. This one is off of Thingiverse, and as you can see, it was an epic disaster. This split was caused by me trying to remove it from the build plate, as it was very stuck. I had put painter's tape onto the bare glass in order for it to get good grip, and up here you can tell that there was an issue in extrusion. I don't know if you can tell, right here on this edge, it's wavy. I don't know what causes that. I suspect that it's the Y or X-axis, as the Z was properly tuned at this point. So I continued to print vases, the exact same but smaller, because I didn't want to waste any filament. And as you can see, they all have that same ridged effect. This is version 2, this is version 1. But you might be able to tell that some sides have it worse than others, and so I decided to mark out where the X and Y axes were, and I discovered that most of the ridges were happening on the opposite side of the fan on the block, and that has an effect on the print as air will indirectly flow down. Keep in mind that there's no part cooling fan on this printer yet. That's an upgrade that I will be doing quite soon in a future video. As I spin this around, you can see that this backside has it the worst. It just goes back and forth, back and forth. I concluded that this wasn't extruder related, as that had also been calibrated, and this was printed in vase mode. So there was constant extrusion, no retractions at all. So I decided to go ahead and print a benchy. And as you can tell, it is terrible. With no part cooling, the bow is quite droopy, as well as a blob from it pausing in the middle. The smokestack is suffering from overheating, as again there's no part cooling fan. You can tell that the bridging on the top suffered quite a lot, also due to the lack of a part cooling fan. But overall, I'd say that this is a good first benchy. Now I decided to go ahead and compare it to another printer. This one was printed on my Ender 3. It was heavily modified. It has a part cooling fan, and as you can see, it is almost flawless. The chimney, you can actually see it looks like a chimney and not a blob. The bow is smooth in the front with no drooping. Keep in mind, this is the exact same G-code. It was only printed on 2 separate printers. One had a part cooling fan, and it was made out of aluminum extrusions. The other is this one, the one that I made, yet to be named, but I have some in mind. And as you can see, the quality between the two is quite significant. This is that same benchy that was shown previous, and it is currently printing. So, moving on to upgrades that this printer so desperately needs. Number 1, a part cooling fan. Number 2 is a interface, an LCD screen. I have one, but unfortunately I burnt it out due to me wiring it in backwards. Yeah. The next upgrade I need is a new Arduino Mega. So, the story goes like this. I had plugged everything in, I was ready to test it. That includes the LCD screen that is no longer connected, and apparently I had plugged in all the end stops in backwards. And so signal was on live, and live was on signal. And so when I flipped the power switch, the board could not handle it, and the 5-volt voltage regulator blew. That's this tiny part right here. So that's what's causing, and that is what caused the LCD screen to not work. So I need a new Arduino Mega, as well as a fan to put in here, as it gets quite hot. I drilled holes in this thinking that that would be sufficient, but it is not, especially for longer prints. And believe me, this printer so desperately needs it. I can only print at 30 millimeters a second, which is quite slow, but also quite conservative, as this setup is not as rigid as I would like. If I wiggle this topmost piece, hardly anything besides the x-axis moves at all. But you see, that's the problem. I also suspected that ripples caused in that vase is caused by this bed not being so stable. Everything on this is 3D printed, so I call this the bed, and this portion underneath is called the undercarriage. The undercarriage is flexing quite a bit. You can tell because when I pull this all the way forward, one of these screws hits the threaded rod, and the other side it's a lot higher up. So I will go ahead and redesign that, and unfortunately I will not be 3D printing it. I have a few ideas in mind, including upgrading to steel or CNC cutting a wooden version out. As also explained earlier, this extruder is quite plagued with problems. The major one being that the spring is not strong enough. There's 2 springs doubled up in here right now, and in order to print, I have to take the spring from my Ender 3 and add it to this extruder so that there are 3 springs at once, and that just barely gives me enough tension or enough squishing force on the filament to feed it through all the way up to the Bowden tube. As you can see, I've marked this with V1. This is my nifty spool holder made out of wood, and that was also a problem in the beginning as I could not get the extruder to pull the filament and rotate a full kilo spool. So I concluded that the issue was due to the friction caused by the spool rubbing on the wood. And so what I did was I took clear packing tape and I wrapped it around these 2 poles, and now it has a lower coefficient of friction, which makes it rotate easier. In the future, I would also like to chop off this extra threaded rod, as it is quite bugging me and also causing the spool, when I put it on here, it gets in the way of the spool rotating, is what I'm trying to say. So yeah, that is, oh yeah, I've also named this. Of course, I've named it after myself, namely being the Gibson Mini. If you enjoyed that video and would like to see more 3D printing or making stuff in general, please consider subscribing and hitting that like button.